Welcome back to The Explainer. Today we're looking at one of those incredibly rare moments in history where someone sets out to solve just one very specific, very practical problem and accidentally creates an entirely different future. We're going to see how a seemingly completely ordinary piece of technology literally laid the foundation for the entire world we live in today. Okay, let's dive into this because the true story of how the modern industrial world was born, it isn't about some grand stroke of genius out of nowhere. It's actually about a single brilliant modification.
Right off the bat, we have to bust a massive historical misunderstanding. If you ask most people who invented the steam engine, they'll confidently tell you, oh, it was James Watt. But that is a complete myth. Steam engines existed well before James Watt ever entered the picture. He absolutely did not invent it. What he actually did was take an existing machine and make it dramatically more efficient. And it was that one specific improvement that unlocked a literal global transformation. It changed manufacturing, transportation, the layout of our cities, and eventually modern capitalism itself. But to really grasp how, we have to look at the very practical problem he was actually trying to solve. So let's rewind a bit to mid-18th century Britain. Coal mines were becoming increasingly vital to the economy, right? But there was this huge physical barrier to actually getting that coal, because as miners dug deeper into the earth, water constantly flooded the underground workings. It was a massive, massive problem. Now, early steam engines were already being used to pump this water out, which, sounds great in theory, but in practice, they burned through literal mountains of coal just to run. If your mine happened to be sitting right next to an abundant, super cheap coal supply, sure, you could manage it, but for anyone else, pumping the water out was just incredibly expensive. The technology worked, but it simply was not efficient enough. Now, what's really interesting about this early setup, specifically the Newcomen engine, is the sheer amount of wasted energy. Just think about this four-step cycle. First, steam enters the cylinder. Second, the steam is condensed. Third, water actually cools that very same cylinder down. And fourth, you have to reheat the whole thing with more steam just to start over. Imagine boiling a giant pot of water on your stove, then dumping a bunch of ice into it to cool the pot down, and then having to heat that exact same pot right back to boiling again over and over and over. That is exactly what this machine was doing. It repeatedly heated and cooled the exact same cylinder. The energy waste was just astronomical. Enter James Watt. In 1765, Watt was a Scottish instrument maker working at the University of Glasgow. He gets handed a small model of a Newcomen steam engine and is just asked to repair it. But instead of just fixing the broken parts, Watt looked at the fundamental design and asked a much deeper question. He asked, why is this wasting so much energy? And his solution was the separate condenser. Watt realized that the condensation process needed to happen somewhere else entirely. By keeping the main cylinder hot all the time and condensing the steam in a completely separate chamber, he fundamentally revolutionized the engine's efficiency. I mean, it sounds like a minor engineering tweak, but it literally changed everything. But as we know, just having a great idea in a university workshop doesn't automatically change the world. Turning an idea into an actual commercial machine, that's an entirely different beast. Watt simply lacked the financial resources to scale this thing up. So, enter Matthew Boulton. Boulton brought the capital, the heavy manufacturing capabilities, and the customer network from his operations near Birmingham. Together, they partnered up and transformed a brilliant little engineering tweak into an absolutely unstoppable business. Initially, these new Boulton and Watt engines were sold to the coal mines just to pump water, basically doing the old job much, much better. But then a massive pivot happened. Engineers realized steam could do so much more than just pump water. It could actually drive machinery, which leads us to a pretty profound question. What happens when power becomes portable? This is the exact moment the narrative scales up dramatically. This is the moment we go from just clearing water out of a ditch to completely unchaining global industry. And this brilliantly illustrates that shift. Because before Watt's improved engine, factory owners were totally at the mercy of geography. You had to build right beside a fast-moving river to use water wheels for power. But with steam power, the factory was unchained. You could put a factory anywhere. You could move it closer to the coal supplies that fueled the engines. You could move it closer to the workers in the growing cities. You could build right next to major transportation networks. Power was no longer tied to a riverbank. It was finally portable. And that completely reshaped where human beings actually lived and worked. The textile industry was one of the first to really truly harness this. Steam engines provided continuous, relentless mechanical power. Production centralized, factories grew, costs fell, demand skyrocketed. What emerged was this unstoppable industrial feedback loop. More machines meant more production meant larger markets drove more investment, and that investment produced even better machines. It was a rapid, self-perpetuating cycle of growth that just exploded and completely transformed the economic landscape. But steam didn't just stay locked inside the factory walls either. It mobilized humanity. During the 19th century, steam power was adapted to drive the development of railways and steamships. Suddenly, people and goods could move across land and water with a speed and reliability that had literally never been seen before in human history. Distance began to lose its economic power. A manufacturer could source materials from hundreds of miles away. A farmer could sell crops to entirely new, completely distant markets. Global trade didn't just grow, it accelerated at a breakneck pace. The world was rapidly shrinking. And as the world shrank, the very nature of human life changed right along with it. Think about it. For centuries, manufacturing happened in homes, totally dictated by daylight and the natural seasons. The industrial factory threw all of that out the window. Work became centralized, and perhaps most importantly, the factory clock became the new master. Production was measured, efficiency was monitored, and human labor became highly organized around the relentless continuous schedule of the steam-powered machine. Time itself was now money. Now, of course, this massive technological shift generated deeply complex social problems. As factories attracted workers, rural populations migrated heavily toward industrial centers, leading to just explosive urban growth in places like Manchester and Birmingham. Cities really struggled under the weight of these rapidly growing populations, which increased pollution significantly, and inside the factories, working conditions were incredibly difficult. Hours were notoriously long, the environments were often highly dangerous, and child labor was utilized across many industries. The Industrial Revolution created completely unprecedented wealth, but it also forced society to confront the harsh, tangible byproducts of this sudden, massive influx of power and centralization. Let's move forward and see how this builds, tracking the literal ripple effect of Watt's innovation across time. In 1765, we have that single, localized invention of the separate condenser. By the 19th century, that technology has matured into railways and steamships, physically connecting the globe and giving Britain incredible economic and military advantages. And this certainly didn't stop at Britain's borders. Other nations quickly recognized this shift and began building their own factories and railways. This aggressive spread of industrialization directly shaped the modern era, completely reorganizing the entire global economy around machines and mass production. Today, the original engine is almost invisible beneath everything we've built on top of it. But James Watt's legacy, it's permanently anchored in our daily lives. The word watt itself became a standard unit of power. Every single time you buy a light bulb or check the back of an appliance, you are seeing a quiet, lasting tribute to the Scottish engineer who fundamentally transformed what mechanical power actually meant for humanity. It's a permanent fixture in our vocabulary. But, this explainer isn't really just about steam. It's about the strange, unpredictable nature of innovation itself. Just look at this pattern of unintended consequences. The internet was absolutely not designed to become social media. The transistor was not designed to put a smartphone in your pocket. The military's multi-billion-dollar GPS was definitely not designed to help you find a half-calf oat milk latte. And James Watt's improved steam engine was absolutely not designed to create the modern industrial world. He literally just wanted to stop a machine from wasting so much coal. The greatest inventions always escape the original intent of their creators. So the crucial point is exactly what this quote captures. The inventor sees a problem. History sees a platform. One single improvement creates a new possibility. That possibility creates another and another until an entire society is completely transformed. Technology, like Watt's separate condenser, merely creates the possibilities. It gives us a new platform. It is ultimately up to society to decide how those possibilities are actually used, for better or for worse. The people who change history are often simply those who manage to solve one difficult, highly specific problem better than anyone before them. Which leaves us with this final thought. The modern world didn't just appear in one dramatic flash of lightning. It emerged from a cascade of seemingly small improvements, just like a separate condenser on a water pump. So, looking around at the tech landscape right now, what small improvement today is secretly building our entirely new tomorrow? What is the separate condenser of our era? Keep that question in mind as you look at the world around you. Thank you so much for joining me for this explainer, and be sure to check out our other explainers to uncover more of the hidden decisions that built the modern world.